can see me. I'm pressing go live now on YouTube, and we should be good to go. So, welcome everyone, and welcome to new community call for Starknet. We are at edition 39. So, as usual, we're live on YouTube and we are live on Twitter. I don't think we communicated that much for that community call, so this might catch you. This might catch you by a random chance. So do stick around, and if you have questions, feel free to ask them either on Twitter or on YouTube. I'm Henry. I'll be your host, and today I'm joined by Sasha. Hello, Sasha.
Hey, Henry. How is it going?
I'm doing well. How about you?
Perfect. Yeah, really good. Thanks.
Did you have a lot of chocolate last weekend?
A lot of what, sorry?
Chocolate.
Oh, yeah.
Nice.
Yeah, I'm pretty lucky, I have to say. Yeah.
Yeah, it's the good thing with Easter. Okay, cool. So, Sasha, you're here to talk about Yearn's Pool Factory. Is
Yeah,
that correct?
yeah, absolutely.
Super cool. So you'll be talking about this in a sec. Let me check that we have everything set up. Oop, I'm gonna tweet this real quick. Just give me a minute. Oop. Okay, I'm gonna do this later on. Don't worry. Okay, so well, Sasha, the floor is yours. So if you want to present what you've been working on, you've been in the ecosystem for a while, right? You worked
Mm.
previously on Magnity. Now you're also working on
Yeah.
Morphine. Can you give us a bit of context of how you came to work with Yearn?
Okay, so I get involved in the Starknet ecosystem for 1 year now, a bit more maybe. So yeah, I started, as you say, I started with Manity, so some projects related to DeFi. So the purpose was to provide on-chain asset management for users. So I worked on this for some months, and finally I get engaged with Yearn on a really cool project. So I contacted Juan that told me about what he wanted to do with Yearn. So on the new version, so maybe I should explain a bit Yearn in the first time so people could understand. So Yearn is a yield aggregator protocol, so that the protocol exists for several years now. So basically, it's a vault that can contain many strategies, and the purpose of Yearn is to like maximize your profit through DeFi. So you can get yields through Ethereum, you can get yields through stablecoin, USDC, USDT. And what they do with all the money they receive from users is that they will allocate all of this money in different strategies on the ecosystem. So the strategy can be a lending pool on Aave. It can be a lending pool on a Compound. It can use Curve Pool, liquid staking token. So what you have with your Lido, they can leverage it, and so yeah, they can use several different strategies through the DeFi ecosystem and optimize it so you have the best yield.
So
And
strategy is really just a set of steps for you to manage your liquidity on Ethereum, right? So
yeah,
you put some
yeah,
liquidity there,
exactly.
you do something with it, then you put it
There
somewhere
is
else.
like a central vault that interact with several strategy smart contracts, which are also like mini vaults. So that's like a big vault containing a lot of mini vaults. And what's complex for Yearn is to find what is the best allocation for this different strategy. Should I put more money into Aave strategy or compound strategy? And that's how that's what the project wants to optimize. What I did with Yearn. So how to make the debt allocation more optimized and more decentralized. So previously, what Yearn did is that they have the governance that decided, okay, I will distribute, let's say, 50% in this strategy because I saw of chain that is performing well, and this allocation to this one and the other to this one. the thing is that it's not really optimized because you never know. It's not really precise. It requires a lot of governance intervention, and it's you never have the allocation for the best yield every time. It gives a lot of overhead in this process, and so the idea was to calculate on-chain this API and allow anyone to provide a better solution, so we could make sure that the new allocation solution is better than the previous one. And this can be done through the sharp prover. So the idea is to calculate through a Cairo script the APY of the different strategy, have a proof that this yield are the good one, and then submit the proof to the sharp, and then it submit to the layer one verifier, on which one you can make sure that you have calculated the strategy API the good way and in a verifiable way. So yeah.
Interesting.
So,
So before what was done is off chain,
yeah,
the yield was calculated by a set of tools, imagine in
yeah,
JavaScript,
exactly.
in a lot of stuff, I
Like,
imagine.
yeah, Python, JavaScript, or I don't know exactly, but yeah, the idea is that it was performed off chain, and then the
Yeah.
governance came and say, okay, this is the new allocation for the
But
vote.
that's just, but when you say the governance, this means that from the point of view of the smart contract, it's really just a bunch of person saying, yes, this is the new allocation. And the smart contract is like,
Exactly,
well, we have to trust these people. But maybe
exactly.
the allocation is just sending it to your private wallet, which is something that can happen, obviously, or maybe it's suboptimal, whatever. Um, and the goal here was to remove the trust factor. And so you made
Yeah,
all these verification, but in a provable manner, meaning now instead of saying, yeah, we did it off chain and we certified that this is correct, you can do it in a way that the smart contracts then says, yes, I see that this was done correctly and that this new strategy is valid.
yeah, yeah, exactly. Now, like
Whoa.
this solution is much more decentralized. Yeah, so you don't need to trust anyone. You can directly verify that the new allocation is better than the previous. And so we needed, yeah, it need the debt allocator needed to be so decentralized. And so if you remove the trust, you need to make it permissionless. So everyone should be able to like propose a new solution, verify it, and then we should incentive these people. So what Yearn did is that they allow everyone to post a new solution using the sharp, calculating this API through a Cairo script. And when the proof was ready on the layer one fact registry, you could calling this the debt allocator again. Okay, this is the new allocation that has been calculated. We can make sure it's better than the previous one, and and the new proposer just verify the new solution and get rewarded through a Llama Pay stream. So that's how it.
Since it sounds like in your program, so you wrote this program, you're the one who wrote this program, is it correct?
I wrote the Cairo script, and we both collaborated on the layer one contract with member of Yearn team.
Because it sounds like in your Cairo script, you have to use data from the blockchain. So I'm guessing you have to use some
Exactly.
kind of oracle or some kind of way to
Um,
tie into data of the blockchain and then convert the data that you have there, which is just a root of some state, to, hey, yeah, the APY is actually this, which
Yeah, you
sounds
need
complicated.
to give the good input to the Cairo script. So the debt allocator contract can so it can accept the several strategies. And when we add the new strategy, we have to specify what are the interesting data to call. So we give like the contract address to call, the all the call data, and we say, okay, what we want from the response, because it can be a structure, so you need to get what you need. I've made a small presentation, so it could
Let's go.
be better if I share it and explain it through this, and then we could go like a bit in the code. Um, so let's try to share the screen. Okay, can you
There
see
you
the
have
screen?
it. I can, and now people should be able to see it too.
Okay, okay, perfect. So yeah, so just to to talk more about the problem. So the thing is that we needed to calculate it on-chain the API of the strategy, which was really too complex. Before it was done by governance, so it was we needed to update frequently the new allocation, so it could put some issues, and it was not decentralized. And to make it permissionless, we could not allow everyone to submit a new solution because we need to make sure the new solution is better than the previous one. So to deal with this, we used the sharp prover to be able to calculate the API of the different strategy of chain. So just a small reminder, so sharp prover will allow you to attest the validity of a carrier program execution and to post the proof on layer 1. So you'll be able to access the proof directly interacting with the fact registry contract on layer 1. And yeah, so now, as I was saying, to calculate the API of the different strategy, we need to have some data from the concerned strategy on chain. So, for example, if you want to calculate the API of AAV strategy, you need to get some parameters of the AAV interest rate model. So it will be parameter like the pool utilization, so it's a linear interest rate model, so in 2 pieces. So you have like a slope and then a kick, and after this, another way to calculate it. So the first step was adding a new strategy and take all the necessary call data so you can access this data. So you need to say everything for each strategy. So some stuff for AAV, some other stuff for compound. Each strategy has its own data, has its own need in terms of data. So the first step is to add a strategy. I add AAV, so I need this, and this, etc. And once you have saved all the necessary call data, everything you need to access the information that will be useful to calculate the strategy API, there is a function which is a save snapshot that will save the current state of the different strategy. So when you call this function, the contract will call all the necessary call. He will just call other contracts like AAV, compound, everything. So he will just get all the data he needed, hash it. So we don't need to save it because storage can be expensive on Ethereum. And better than saving all of this, we just hash it all, save the hash, and emit an event with all the data that we received. So yeah, this is like the second step. And once you have all of this data, so you get it from in the event that you emitted, and then you can put all of this data in an input for the carrier program. So it will have all the data it need to calculate the different strategy API. So yeah, you arrive with with a lot of information that you receive from the Solidity event from the save snapshot function, and you add the new allocation that, in your opinion, will provide a better general API. So you can say, okay, so right now there are two strategies. You put all the data you receive from the event, and you say, okay, I want to have 50-50 on the allocation of those two strategies. So I'm going to run the carrier program, and when you find a good solution, so you can like basically brute force and find the optimal solution, putting different allocations. So let's try 50-50, let's try 20%, 80%, etc. And once you found the best general API, when you found the perfect allocation, you can submit the execution proof to the sharp. So the sharp is going to receive many cairo trace and will submit a proof to the verifier on layer one. And then we'll be able, the proposer will be able to verify this new solution on the layer one. So he will call the verify solution function. He will provide the output from the Cairo program. So that will be basically the hash of the safe snapshot function. So to make sure we use the good input. It will he will also provide the new allocation, the previous allocation, and then the contract will check on the layer one factory registry to make sure it's true. What we provide in the verified solution is true. The new allocation indeed provide this appear and is indeed better than the previous one. And indeed, we use the good data. So we'll get the hash of the input. We'll compare it with the one we stored when we did the save snapshot function. If it's good, we'll then check on the layer one, the factory registry. Everything has been performed in the. Everything can be verified. Everything has been performed well, and then it will be updated. And so you, as the proposer that provided a new, better solution, you will be paid through Llama Pay. And so this system creates kind of on-chain competition that incentive everyone to provide a new, better solution than the previous. And as a consequence, the vault always, always or almost always have the optimal allocation. So yeah. And this is
It
a bit.
sounds really interesting. What's funny is that so the fact I like the snapshot idea. I think it's fun that you're asking the smart contract to take a snapshot of some interesting parameters and then you reuse these later on. I'm wondering how easier this is rather than using something like, say, storage proofs, for example.
Yeah,
But I'm guessing probably when you did that, the tooling wasn't there yet.
no.
And also, when I start thinking about the complexity of the Cairo program to take all of these parameters and to have
Yeah,
something that is generic so that you don't have to submit a different Cairo program every time, my mind
yeah. The
gets
thing is that,
lost. So adding even more complexity to that sounds daunting.
yeah, because so when we check, when we verify the proof, so it's like basically you do a KCAC 256 between the Cairo program hash and the program output. And yeah, the Cairo program hash has to be unique. It's not like we need to calculate the APY of different strategy, and each strategy has its own calculation method. And in the Cairo program, we do not want to, we can update it, but we didn't want in our design. So we had to provide moreover than in input than uh, the, uh, the, the good information like current utilization on Aave. We have to provide also the calculation method for each one of this this strategy. So we have like a kind of a code to represent an addition. We have another kind of code to represent a multiplication. We need also to say, okay, take a certain calculation step and multiply it with another. Like, yeah, we could have for each of our strategy a unique Cairo script, but we decided to gather it all and to provide as a call data the calculation method of each strategy. So it can become really complex if the strategy calculation is really complex. But for our case, it was okay because we only used compound and Aave, and basically it's just a linear function, and with if a certain condition is respected, it's another linear function. So it was fine, but yeah, because you always need to specify the Cairo program hash. So what's your Cairo script when you want to verify the solution? Yeah, you need to make sure it's the good Cairo program. So yeah.
Yeah, and if you change the Cairo program every time, like the Solidity contract doesn't know what is in the Cairo program, so it's a governance vote. So if you have to change your Cairo program every time, you're back to square one.
Yeah, and then you have other govern, you have other, then there are some decentralization problem. You have
Yeah.
additional governance. So yeah, but I think the way we did is okay when you calculate when it's not too complicated for the calculation, but once you have a lot of calculations that in which one you have a lot of condition, in which one you have a lot of operation, it can become very, very difficult. Like even to save the calculation method on AV, which is a really simple calculation, it was quite long, and yeah. So yeah, it depends. I don't know if it's maybe so. This is like a resume of all the different steps. So so you had your multiple strategies, which with each one the calculation method inside, the call data inside, everything. Then you save snapshot, you save the hash. So you'll make sure after when you will verify the solution that you have used the good input. So when you've saved the hash, you get the data from the event. You will use this data in the Cairo program. You will run the Cairo program. You will submit the proof to the sharp. One you can accept the fact on the layer one verifier. You can call verify solution, and the new allocation of the Yearn vault will be updated if indeed your new allocation provide a better appear than the previous one, and you as a proposer will get incentivized. So right now it has been implemented with a llama pay stream that each time do a stream of money to the last proposer. But yeah, basically there are other methods. And yeah, this design could have been done using storage proof, and like you could basically describe the calculation logic on Starknet, make some contract, add a new calculation method for the appear, and then get access the layer two data in layer one. So yeah, so this is another design that could have been done also, but yeah. Right now we did with the sharp, so it works pretty well.
Super cool.
Yeah, I've also some code. If I can also show some piece of code, it's called.
Yeah, that'd be great. Looking on YouTube, if there are questions, no questions for now, and no questions on Twitter. I'll repeat it. If you have any questions, feel free to drop them there, and we will, and then we'll answer them live. So yeah, if you want to show some code, Sasha, go ahead. That's great.
Yeah, sure. Okay, can you see it?
Now we can.
Okay, perfect.
Can you make the font a little bigger, please?
Yeah.
Just a little. Yeah, good.
It's good?
Yep.
Okay, so
Oh, and you wrote all of this in Cairo 1 or Cairo
oh,
0?
Cairo 0, but I have to
Nice.
change it to Cairo 1. So this is the Cairo 0, and yeah, so because I updated the VS extension for Cairo, now and not read anymore.
It's all
Cairo.
right.
Yeah. What should I start to explain the layer one, the depth allocator, so the Solidity contract or the Cairo script?
Up to you. If we can go over the Solidity one, I'm curious to see how you did that.
Yeah. Okay, so let's start with the Solidity contract.
Are you freezing? Is this me?
Oh, am I still
Nope.
freezing?
No, looks like you're back.
Okay, perfect. So let's start with add strategy. So when Yearn wants add a new strategy, he has to provide additional information regarding the strategy if it uses the data allocator system. So it has to provide the call data, so all what we need to call the good information we need. So for AAV, it will regard some parameters such as the pool utilization and what APR it gives you regarding the pool utilization. So this is a structure which is so strategy param is defined here. Yeah. So you have to tell, okay, which contract I have to call, the sector, so which method I have to call, and then the call data. Sometimes, yeah, you have to provide some call data. For example, you have like a data provider contract on AAV that asks you that a function that can be get pool info. So you have to provide the pool in the call data. The offset will be useful. So you call it and you get a certain response. And the response can contain many arguments. It can return a structure. So you want to just select what you need. Then the calculation. So as I told you, because we are not updating the carrier program hash each time we add a new strategy, we do this in a generical way. So we have to provide the calculation data. So the carrier script will understand how to calculate this strategy. So the calculation data, can I explain it here? Okay, so basically it's kind of easy. You just have to provide the first member. Is it a member that you get from the data emitted by the event Snapshot, the data you have when you the data from the strategy, or is it or is your first operand regard the result of a previous calculation step? Then you have to do this with the second operand, and then you have to provide what operation. So 0 represents an addition, 1 a subtraction, 2 a multiplication, and 3 a division, and then some other rules for power or root or whatever. So you provide
Did this strategy, like the modeling of how you calculate strategies, is it something you came up with for this project, or is it something
yeah.
that was already implemented and done?
No. I use it especially for this project. So it's not like I would say super optimized, super clean. It's just a way to do it.
It works. Okay.
Exactly. And yeah, also there's not only calculation, but there is also condition. So as some of you may know, the AAV interest rate model works in two linear pieces. So the first one is when the current utilization is before the optimal utilization. So it's just a coefficient multiplied by the current utilization. And if it's after the the optimal utilization, you'll have it will be rapidly increased to avoid like the pool to be fully borrowed. So it's just that with a certain condition, you will have another calculation method. So yeah, we also added a method for the Cairo script to know if there is a condition, and if there is a condition, jump to a certain calculation steps. So in the calculation array, there is the calculation method of the first condition and of the second condition. And if the first condition is respected, the Cairo program will know he has to jump to a certain step of the calculation. So another calculation method. And yeah, let's go back here. So here, pack strategy is just because we don't want to save the previous strategy parameters. So we just hash it and just save the hash. So we don't need to every time we add a new strategy, we have to provide all the previous one in the call data. So it's used in memory. but we don't store anything. We just make sure that the previous strategy, when we hash it, we refine the hash we have calculated before. So yeah, this is just to make sure we use the previous strategy had a good one. So the address of the new strategy, the strategy param as I show you. So then I won't explain that much. The update strategy and remove strategy is just there are a lot of things to manage because we save hash for all the previous one, but whatever. Let's check save snapshot. Okay, so check at least one strategy. So it's just to make sure you have at least one strategy registered. Then you'll check the strategy hash. So as I told you, we are not saving all the strategy parameters. We just hash it. So we have every time we want to use it to provide it additionally in the call data. We just make sure it's a good one and we continue. This is some conversion stuff to call because we saved in the strategy param a lot of contract selector call data, and we just like make it good so we can use it to call contracts. And then you have get strategy data. So I will show you this function. So what does it do? Basically it will call so the address that you provided in the parameter, the selector, and yeah, as I told you, we needed to provide an offset to make sure we get the good information from the whole structure that is returned. And yeah, so we get from this all the data strategies. And yeah, now we have the data strategies. We hash it all, and we save the hash. So here we receive all the data we needed for the strategy calculation. We hash it with the calculation and conditions, and we store the hash for a certain timestamp. So now we store this. Once we will verify the solution, because we also provide this hash in the Cairo output, we will make sure that what we send to the Cairo, what we use for the Cairo script was indeed this data, this calculation, and these conditions. So it's just to make sure it's fair. And then we emit the event. So the users that called save snapshot can retrieve all this data, because here we save the hash, so we don't have access, and here we just emit it. And so maybe I'll transit to the Cairo program now, because that's before calling verify solution, we have to run the Cairo program. Okay, so it's not really beautiful because of all of this red underlay, but so how does it work? Let's go to the main function. Okay, so in the program input, here we can see really good, but we have so the current allocation, the new allocation that we want to test to see if with this new allocation we have a general better solution. The strategy data, so this is all what we get from the save snapshot events, as I showed you just before. So data, strategy calculation, and finally a bit later strategy condition maybe. But yeah, whatever. That's the idea. So we obviously we don't type it manually. We have a script that is able to find the last events. So from so we can directly get all of this data, put it in the JSON, and run the Cairo script. So in the Cairo, we are going to get the current allocation, the new allocation. We are going to take the calculation and the condition, and then that's a lot of just a code that basically just calculate the API.
We have a question on YouTube. I think it's more related to your L1 contract, but one is saying, why not have an intermediate L1 contract that computes the needed parameters? I think that's what you described earlier. So the L1 contract gets the parameter and saves a snapshot for these. The second question is, how does the verifier contract validates that these parameters are correctly formed? For example, that you're indeed calling the Aave contract and you're calling the valid method. I see that you're doing a call to a contract. What prohibits me from sending an array where you call approve on Aave and then transfer on or to send me money?
Like in the when I verify the
In the
solution, then
in the
how
solid
can
no, in the solidity
yeah.
part where you record the strategy.
Oh, okay. Um, so this when we had a new strategy, all of these parameters. So this is the governance that says. So you have to like strategy. So here, the question is how can I make sure these are good ones? Is it
Yeah, that there's no that using these won't steal money.
okay? So this is a function that is used by the governance.
Ah,
So
okay, so anyone cannot just submit something. It's
no, no,
through
no, no.
multi-sig.
Everyone, so
Understood.
this is really Yearn that the governance that decide to add a new strategy to his vault, to the vault, and yeah. So here you cannot. It would be complicated to make sure this to make it permissionless and allow everyone, because yeah, here you provide everything you need to for the strategy calculation, for the strategy data you need. Yeah, so this is done by governance, and this should be done in a good way. That's yeah, that's it.
Well, yeah, okay. It's
We
interesting to
do
think
like
about roundabout ways to do this, but okay.
yeah, might be a bit complicated. So what we do at least is some call check before we add it. So we still call the contract, the selector, and we make sure this works. This returns some things. Um, but yeah, it's in this function. Um, yeah, so we still do a call to make sure. So it's not like fully optimized, but yeah, you can do some additional checks or when you add a new strategy to make sure uh, it call a real contract, a real methods.
Hmm,
But yeah, yeah, this is
nice.
done by the governance, so you cannot like can be
Just do
complicated.
it. Okay.
Yeah,
Sorry, I interrupted you when you were on the
no problem.
calculator.
No problem. So yeah. So I was saying that we put everything as an input in the Cairo program in the JSON. Then in the Cairo program, we take all of this data and we run what is called uh, run input. So we basically calculate score. So what we provide is the current allocation, the new allocation, the data strategy, so current utilization on Aave, slope one on compound, whatever, calculation strategy, condition strategy, and this is like because it's recursive, we need to like we save a certain score for each allocation, and we just calculate the first strategy, appear, we multiply it by the allocation on this strategy, and we add it to the score, and we call again it. So it's just a recursion function. And so how does it work? Um, so this is just the recursion stop. So when it's over, just return stuff. This is prepare calcul. So as I told you, there are some strategies that require a condition. So this function will be used uh, tell where is the index I should start in the Caro in the input calculation. So it will just check if a condition is the condition provided is respected. Yes, we jump to a certain calculation step. No, we keep at the first the index 0 for the calculation step. So yeah, it's just yeah, we just check the condition and go to a certain step in the calcul. So then there is the calcul score strategy. So this is the function that will from the calculation method and and the calculate and the data calculate the APR of the strategy. So yeah, so how does it work? The first thing is like to choose your two operands. So do I want to multiply? What do I want to multiply? The current utilization on AV with with a certain constant or whatever. So here, the first step is to select your two operand. What will be the two terms of your calcul? That can be division, multiplication, or whatever. So there is we did a certain things. So if the first operand is before 10,000, it means that it represents the index in the data array. So the index of the so you can have like in the index 0 the current utilization, index 1 a certain constant. So here you just take the good one, the good index. Then if it's over 10,000, we are just taking the x less 10,000 steps, so to access the previous step. So let's say I calculated current utilization multiplied by this. Okay, I have this result. Then I want to do this, some things with this result. So here I will just take as a first operand the result of this last operation. So, and if it's over 20,000, it means that it's a constant. So if you want just plus constant, less constant, divided by constant or whatever, we just take the number and we subscribe. We make sure it's a constant if it's more than 20,000, and then we take this number, subtract less 20,000. So we do the same with the second operand, and once we know each what are the two operands, we perform calculation, and from this, wait, I'm just looking for the function. Okay, this. And so yeah, now we have our two operand, and what will be the operation? It will just depends of the operator. So as I told you before, if it's a 0, it's a plus. If it's 1, it's a it's less, then it's multiplied, then it's a div, then it's po, and yeah. So you have a different methods. So that's how we have a generic method for APY calculation in the Carol program. We always provide the calculation method as input, and then the Carol program will detect what is the calculation. Once it's done, it's calculated. So yeah, it will calculate the current allocation APY and the new allocation APY. And finally, it will print it as an output. It will output what we need. So what we want to output, we want first to output our input. So we make sure we calculated with the good values. So this is the hash that have been saved during the save snapshot function on the layer 1 solidity. So we can calculate it. We calculated directly through the Carol program, and then we store it. We output it. Then we'll verify on the layer 1 solidity that it's a good one. Why we need? So it's felt. You cannot print a Yearn 256 with like this. So we print 2 felt. And then we serialize array with the current allocation, new allocation. So the current allocation will be then used to make sure the current is a good one, and the new allocation is also the new one you provided, and the previous APY and the new APY. So it's important to calculate the previous APY because it changes every time. So you may let's say you have saved a 3% general APY for your solution. If you recalculate it, it can be more or it can be less. So it's important to calculate it again in the Carol program. And output it. And then the new API, and then then you have everything you need in the output. You submit, so you do Caro submit to the sharp, and you will have a job. And yeah, so once you submit it to the sharp, you want to verify the solution on the layer one. So we go back in the solidity code, and now we want to call verify solution. So in the verify solution, we are going to add everything that has been output in the Cairo program once we run it, and yeah. So the first thing is to check the strategy hash. So this is what we saved in the wait, strategy hash. Yeah, this is just again, we are not storing anything for the data, so we need each time to provide this, but do not worry about this. So the first thing is to make sure when we save snapshot, it has not been stale, because you don't want to use data that have been provided like a month ago. So you need so there is a certain limit, like 1 day after you save the snapshot, these data are no more valid, because you want to use fresh data each time to make sure it's true. This is just parsing stuff. This is check program output. So this is kind of important. So these are just classic verification, but what is important is here. So we make sure the new solution is better than the previous one. Also, we introduced a little gap to make the user experience better. Because if like you provide a new solution which is like 0.00001% better than the previous one, so it can be a problem for the previous proposer. So yeah, there is a little gap. So you have to like make it better, but more than better. You have a little gap. And what else? Then we need this is important. So the get fact function. So what we do
So
is that
here you're taking the output basically from the sharp verifier to make sure that indeed it was the combination of a specific Cairo program on a specific run and that it was run correctly.
yeah. So here we need
Nice.
to provide the program hash and the output hash. So this is like the magic stuff. You can get the fact by with KK256 of the program hash and of the output hash. And once you have this fact, you can call the layer one fact registry. Yeah. So you can call the verifier. So this is just an interface to the verifier. So we store the address of the verifier, we call it, we send this fact, and we make sure, yeah, it has been executed. And then when it's everything's good, we update the allocation of the vault, and we initiate a streaming fees for the last proposer. So to incentive people to update the new solution.
Now we've come full
Yeah.
circle. Really interesting.
Yeah, so I think maybe
Yeah,
I can
well,
show you a bit how I find the strategy parameters for calculation and condition.
we're reaching about 50 minutes in the
Oh,
community call, so I think we're going to
okay.
wrap it up there. But where can people find more? How do they reach you, and how do they ask you questions about this?
They can reach me directly on Twitter, on Telegram. On Twitter, I like
What's your
write a
handle?
little
How
thread on which one you can access the Git of the repository. You can check the code. You can also contribute. Also, if you can
can
like,
you share the link here, please?
yeah, sure. Um, okay. Should I drop it in the chat?
Yeah, perfect.
Okay. Okay, so here's the GitHub. I can also drop my Telegram if I have any question. Feel free to
Yeah,
reach.
sure. Spell it, and then you can spell it, and people will reach it.
Yeah, and I think like you can use some similar stuff to calculate RV interest rate model to update each time the good solution, the optimal solution to calculate to find the best deal between supplier and borrower. I think you have many other applications. Uh, I would say you can largely do cool stuff with gaming also on layer one and use this system to prove
Your
like
communication is breaking up a little bit.
oh, can you hear me well?
Yeah, now we can hear
Yeah.
you.
Yeah, I was just saying that you can like use this system for many other use cases, including on-chain gaming, DeFi.
I
Uh,
think this whole concept of delegating code outside for it to be checked inside the blockchain is really powerful. Like we usually
yes,
think about layer twos and layer three, but the reality is that it's not a step, it's a spectrum. There's a lot of stuff you can delegate off chain, whether it's a chain or it's a full-fledged Starknet outside.
yeah,
It's really interesting.
yeah,
Cool.
definitely. Yeah, it was a pleasure to work on this. Yeah, for me, that's super interesting.
Amazing. Well, Sasha, thank you for spending time with us today.
A
I
pleasure.
think we're going to wrap it up. So, as mentioned, I've put in the description on YouTube the repo you shared as well as your Telegram handle. And to everyone listening to us, thank you. And